Hi, good morning. Welcome to my lightning talk. In this session, I'll talk about software rendering in AOSP. Some disclaimer about the logos and the product names which I've used in this presentation. About myself, my name is Amit Pundir. I work in Linaro. I've been doing Android bring up and maintenance on development devices for last 10 plus years now. You can find me on these IRC channels. Agenda for this lightning talk is, again, as I mentioned, it's the software rendering in Android. Android bring up on newer or resource limited devices is always challenging, but it is a great learning experience and you get to learn a lot about the Android operating system. And today I will share my experience and findings of running Android with software rendering. For the sake of keeping the things simple from the lightning talk point of view, I'm assuming that the audience has a fair bit of understanding of the software stack. I'll not be talking about the graphics allocator or the hardware composer and other OpenGL things. Right, so the first things first, why do we need software rendering in Android? Especially, why do we even bother running an interactive and user-oriented OS like Android with software rendering, considering that the overall system performance will be significantly slower compared to when using the hardware accelerators, especially for graphics intensive tasks, where the Android system will in that case rely on CPU based rendering instead of the GPU. Now the ASP builds with software rendering can be useful for a number of reasons which I have listed down. These are just based on my experience so far. The obvious bit is that you don't have a GPU on your device, right? So either there is no GPU on the device, or we are running ASP on a device with a very limited GPU capabilities, like some legacy hardware if you have any. Or we are running or testing Android on virtual platforms. Next up is the broken software. Broken or limited software support for the GPU can also push you or encourage you to try software rendering on your device. You may be running ASP on an early device prototype with limited software support, or the broken software support because of missing or legacy GPU binary blobs. The other usual suspect here is the headless Android. You are running Android on an embedded or low platform device which do not depend on display for the functionality. Next up is testing and development. You may be running Android with software rendering to debug or isolate GPU specific issues. Right, so how do we do that? How do we enable software rendering in Android? SwiftShader, if you guys are aware of, it's a software OpenGL implementation used in Android as well as in Chromium. They got rid of the OpenGL implementation some time back, and they now rely on something called Project Angle, which is almost native graphics layer engine. Now to enable the software rendering in AOSP, we used Angle's OpenGL implementation on top of SwiftShader's Vulkan implementation. So it's like there's not a single library which does that now. Earlier it used to be only a single library. If you are an old timer, you must be aware of libgles Android. It used to be the thing at that time. Then SwiftShader, now we have SwiftShader plus Angle. This combination, I think it's, at least it's been written as SW Angle. I used to call it Swangle. So there's no, I've not seen anyone saying it as Swangle, but at least in online in groups you can see that they always club the words as Swangle. These are the relevant device configurations which we set, the standard product packages specific to Angle, the Vulkan implementation, and the vendor properties. Now for the complete reference, you can take a look at the Linaro software build target in AOSP. It's already upstream, it's part of AOSP. It's a software rendering build target developed and tested on Qualcomm platforms, but it is generic enough to run on any ARM64 device. The only catch is the Android boot device, which you have to set using the sysfs, but there is a new solution for that as well. Here are a couple of noticeable changes that we did in narrow software build target. First one is that we switched to the OpenGL backend of Skia instead of the default Vulkan backend, because if you use the Skia Vulkan backend, you will see the display glitches. So we figured out that it's a limitation in the software stack, and if you just use the OpenGL Skia backend, you won't at least see that kind of glitch. The system will still be slow compared to the build if you are running with the hardware accelerated display, but at least you will not see the glitches. And then we disabled the compressed image format to simplify the rendering bits. Right, so next up is bringing up Android with software rendering but on a virtual display. So stepping back to the previous slide, this target still needs an actual display to connect to. Right? So here I'm talking about a virtual display. You can use the virtual drivers. In the older days, there used to be virtual frame buffer. Now we have virtual KMS driver, which we make use of. This slide targets the build configuration with no physical display attached to the device. Right, so to begin with, you make sure that the Linux virtual KMS driver is enabled. It can be part of your vendor GKI module if you are playing with GKI. If you are using a standard kernel builds, you can just enable it and get started with that. The device configuration is exactly similar to what we have seen with what you can find in the narrow software builds. We just need to take care of certain details that can make or break the system. Right, so make sure that the hardware composer device is pointed towards the correct set of device display node. If you have more than one display device driver enabled, then you will have more device cards or display cards there. So just make sure that this vendor hardware composer DRM device is pointed to the virtual KMS device. Then you need to label if you have SE Linux enabled or enforced, then make sure that this DevDRI card of yours is a GPU device and it's not a graphics device. And then the last one is disable the prime shader cache. It is very useful. We were lucky to just stumble upon this after doing some quick graps in the code base, and yeah, because it's not really mentioned or spoken about anywhere else otherwise, right? So what it does is it speeds up the boot time by it reduces your boot time to half. If you just boot the standard configurations, you will see that it boots in about 120 seconds. If you just disable the shaders, which it compiles the shaders before the boot up time, if you just skip that part because you are not actually displaying anything or you don't care about the display, then it can bring down the display to 45 to 60 seconds. And that's all about it. If you have any questions on this, yes, please.
How do you avoid color conversion? Do you use hardware for that, or do you have a way to have the full stack not do color conversion? For instance, for a camera.
Sorry, I did not get the question. Is it about the?
For instance, you have RGB 555 inside the camera, and the displays use something, and this costs a lot of performance. Did you find a way to avoid that?
Oh, I have not tried that. So this is just a pure configuration which I'm using. Sorry, so the question is that instead of using the default RGB 565s or other formats, if you switch to some other display format, then can we reduce the boot time? So I have not tried any of these. What I tried was that since it's a virtual display, I don't care about. What if I don't boot with the default 1080p display or the default?
Sorry, it was for not the virtual display, but for the real.
Oh, the real. So okay. So the question was from the real display point of view. Again, sorry, I have not. So other than the compressed image part, we have not played with it. No.
So would this be a viable solution for a production headless use case, or is there still a performance overhead in this?
Right. So David's question is about using it as a production build for a headless device configuration. So if you have a device which is capable of, because we are not getting rid of the display subsystem as it, right? We are just making sure that it is running somewhere in the background, and we are not just dealing with that, right? So if your system is capable of performing fine, even with, let's say, with a software stack still running in the background, and then sure, yeah. I don't know if you want to do that. So it depends on the use case. For example, if you have a device which is running, so if you have an application stack which is based on Android, right? And you have few services which, because Android services are very tangled up, right? So you don't know at what point your dependent service will depend on something which is exposed by Surface Flinger or any other graphics stack. So if you want to take care of that, then it makes sense to have maybe a dummy display stack running in the background, so that at least your application which has dependencies on this can keep on running. That will also help you migrate your applications from one device to another device, because the stack is the same, right? So if you're running it on a server, or if you're running it on an edge device, then just take the build and, I mean, just guessing, pure guess. I have no idea it will work or not, but yeah. All right, I think we are right on time. Thank you very much.